Hey guys, it's time for another intriguing science lesson with Miss Yee. This is the part where you clap at home. In class today, you guys did a demonstration on objects that would sink and objects that would float. And some of the results might have been surprising to you. Like for example, when the tiny little paperclip was placed in the water, it sunk to the bottom of the sink, while a 10-pound bowling ball floated. So what causes this to happen, you might ask? Get your notebooks ready. It's buoyancy. As you're watching this video, be sure to write down key words and phrases in your Cornell notes. Also, don't forget to write down examples because sometimes it's the examples that really help you more than the definition. So what exactly is buoyancy? Buoyancy is an upward force on an object that is partly or wholly immersed in a fluid, and fluid covers all liquids and all gases, so don't think that fluids only apply to water. We have to take into consideration the density of the object and the density of the fluid. We also have to consider the weight of the object and the weight of the fluid displaced. Remember, displaced means moved out of the way. So we're not talking about the weight of the entire fluid, we're just talking about the weight of the fluid that was moved by the object. So let me ask you this. Is buoyant force being applied on you right now? Answer it in your notebook, yes or no. If you think yes, tell me what might be causing that upward force. If you think no, explain why you think there's no force acting upon you right now. Let's go back to that poorly drawn diagram from earlier in the video. So buoyant force is applied on both objects, the paperclip and the bowling ball. But just because a bowling ball is heavier doesn't mean it's going to sink. Remember from our previous density lessons, it has to do with the material and it has to do with that mass to volume ratio. We know that a bowling ball is hollow, and although that's a lot of volume, that's really not as much mass compared to the little paperclip, which is made out of metal, and that mass to volume ratio is much bigger. Before we dive into the complexity of buoyancy, let's talk about the three types of buoyancy. There's positive buoyancy, negative buoyancy, and neutral buoyancy. With positive buoyancy, the object is less dense than the fluid it's displacing. The weight of the fluid displaced is actually equal to the weight of the object, which makes the object float. If you think about when you're swimming in a pool, you float, and that's because the buoyant force coming from the water that you're in is a lot stronger than the pressure applied by your body weight. You may have heard of the Dead Sea and how people can float with ease, like this guy reading the newspaper. The reason is because the Dead Sea has such a high salt concentration or salinity concentration in the water. When we add salt to water, it increases the density of the water, which then increases that buoyant force. Let's talk about hot air balloons. Remember, gases are fluids too, so they have buoyant force. We can put gases like helium and hot air and even hydrogen into these balloons, and what that does is it increases the volume but decreases the density, and this is why hot air balloons float. Let's talk about negative buoyancy. With negative buoyancy, the object is more dense than the fluid it's displacing. The buoyant force is less than the weight of the object, which means the object is going to sink. Think about a submarine. Submarines can be above water and below water, hence the name submarine. To make the submarine sink, it fills up these tanks with water, which increases the density of the submarine. Now it's heavy and buoyant force can't hold it up. If you think about it, this is how boats sink. The buoyant force can no longer hold up a boat if the boat is filling up with water, causing it to become more dense. Last but not least, we have neutral buoyancy. This is where the density of the object is equal to the density of the fluid displaced. The weight of the fluid displaced is equal to the weight of the object, just like positive buoyancy. But in this case, we don't have floating, we have suspended objects. Scuba divers are trained specific techniques to regulate buoyancy underwater. To stay suspended, they use a buoyancy compensator, which is similar to fish, which have a buoyancy compensator of their own called a swim bladder. Not only do we use buoyancy compensating for scuba diving, but we utilize it to train astronauts. In fact, there is a buoyancy lab, neutral buoyancy lab to be more specific, that trains astronauts to float around on the space station, but in this case, they train underwater. Let's talk about those 5 objects we threw into the sink today. In your notebook, write down those same 5 objects that we placed into the sink and tell me what type of buoyancy was shown. Was it positive, negative, or neutral? Take a moment, pause the video, and write these down in your notebook. Notice how none of them are neutrally buoyant, and that's because none of these objects suspended in the water. They may have taken a longer time to sink and then come back up to the top, but none of these objects actually suspended. Alright guys, let's summarize what we just learned tonight. Buoyancy, upward force on an object that's partly or wholly immersed in a fluid. And remember, that is both a liquid or a gas. And we learned about 3 types of buoyancy: positive, negative, and neutral buoyancy. Positive buoyancy causes those objects to float. Negative buoyancy means that the object's going to sink. And neutral buoyancy is when that object is going to suspend. Alright guys, one last thing. We're going to take it back to the 90s. First, log on to Schoology, onto my page. Click on the assignment, Bill Nye Buoyancy. You're going to watch an episode on buoyancy, which I think that Bill Nye does some great demonstrations to help you understand how buoyancy affects everyday things and what affects buoyancy. Make note of those demonstrations and answer the post-video questions. We're going to discuss them in class tomorrow. Also, be prepared for lab. If you have any questions on what we just learned here, write them down in your notebook so we can discuss them tomorrow.